All right, day 3 notes. So day 1, we did mole to mole ratios. Day 2, we did grams to moles, then the mole to mole ratio, and then back to grams to moles, or moles to grams. Today, we are adding another step, depending on what the question asks. We're going to talk about particles and volume. Remember this guy, the mole? We keep talking about him. 1 mole equals 6.02 times 10 to the 23rd atoms, molecules, or formula units. So those are the particles that I just mentioned. Also, do you recall chapter 8 or unit 8? 1 mole equals 22.4 liters for any gas at STP, and it must be at STP, standard temperature or pressure, or else you cannot apply the 22.4 liters. But in our cases, we will always be at STP unless we tell you otherwise. So these two conversions, units of measurements, you cannot forget. We will use these, and they're also on the back of your periodic table. So let's look at a question. How many grams of aluminum can react with 336 liters of oxygen? Well, I've already given you aluminum plus oxygen. So what's going to be my products? Well, this is synthesis. You have aluminum and you have oxygen coming together, so you will get aluminum oxide. Let's go ahead and do our chemical formula. Aluminum is an element. It's monatomic, so you just write Al. Oxygen is an element, and it's diatomic. It's Brinkelhoff, so it is O2. Aluminum oxide is a compound, and it happens to be ionic. So you have to show your charges. +3 and a -2. Crisscross applesauce, you get aluminum oxide, Al2O3. Now we have to balance it. Bam. Remember, if you don't know how to balance or you can't do it in your head, please use the tally system. Nothing wrong with that. You must give me the known and unknown. We know we have 336 liters of oxygen. What are we asking? If you don't know, go back and read it again. How many grams of aluminum will react? So I'm looking for grams of aluminum. I have to start with 336 liters. So that means I'm going to have to do a mole to mole ratio in order to get from oxygen to aluminum. So I'm going to be using these two right here. All right, start with what you're given. 336 liters of oxygen. Is there a conversion between liters and moles, maybe? Because I need moles in order to go from, like I just said, 3 moles of oxygen for every 4 moles of aluminum that reacts. So I have to be in moles to do that. So I need to convert my liters to moles. And there is that handy-dandy conversion I just mentioned. For every 1 mole of oxygen, there are 22.4 liters of oxygen. Liters on bottom, of course, because we need to cancel out. 1 on top, 1 bottom. So those cancel out. Now I have moles of O2. Now, since I'm in moles, I can convert from moles of oxygen to moles of aluminum. Why moles of aluminum? Because I want grams of aluminum. So I first have to be aluminum before I can convert to grams. So for every 3 moles of oxygen, there are 4 moles of aluminum that reacts. So oxygen has to go on the bottom in dimensional analysis, so they'll cancel out. So there's your 3 moles of oxygen for every 4 moles of aluminum that reacts. Now, moles of oxygen cancel out. I have moles of aluminum. Is that what I'm looking for? No, I need grams of aluminum. So think grams. What do you have to grab? Your periodic table. When you use your periodic table, find the molar mass of aluminum, because the molar mass units is grams per mole. So 1 mole of aluminum has an atomic mass or molar mass of 26.98 grams. Moles on bottom, of course, because that has to cancel out. The point of dimensional analysis is to cancel out your units. So 26.98 grams of aluminum, is that what you're looking for? Yes, grams of aluminum. So we are done. Plug and chug in your calculator, and you get 5.4 times 10 to the second power grams of aluminum. Remember to check your significant figures. We have 3 given to you, so we must have 3 in our final answer. Let's work one more problem. So, using the same equation, how many formula units of aluminum oxide can be produced from 137 grams of aluminum? There's the equation from before. We already worked it out, so there it is. Write down what you know. You have 137 grams of aluminum. What you looking for? You're looking for some FUs of Al2O3s. Start with what you're given. 137 grams of aluminum. I circled these two right here because I have to convert using mole-to-mole ratios aluminum to aluminum oxide. So my first goal should be convert my grams, because that's what I was given, to moles of something. And in this case, it's going to be moles of aluminum. So since I have grams in my dimensional analysis, I need to have grams on the bottom of my dimensional analysis, so it will cancel out. Remember, if I have grams, you must use your periodic table. The atomic mass for aluminum is 26.98 grams. That goes on bottom for every 1 mole of aluminum. Why? Because anytime you use the molar mass on the periodic table, its units is grams for every 1 mole. Okay, so the grams cancels out. You're left with moles of aluminum. Now, since I have moles of aluminum, I can use my my mole-to-mole ratios to give me what my target is. My target is aluminum oxide. So for every 4 moles of aluminum, there are 2 moles of aluminum oxide produced. 4 moles of aluminum must go on the bottom. Why? Because they have to cancel out. Moles on top, moles of aluminum on bottom. That cancels out. You're left with 2 moles of aluminum oxide. Is that what I'm looking for? No, I want FUs of aluminum oxide. Is there a conversion between moles and formula units? Does Avogadro ring a bell? Remember, for every 1 mole, there are 6.02 times 10 to the 23rd formula units, or atoms, or molecules. And in this case, we want formula units. So moles must go on bottom. For every 1 mole of aluminum oxide, there are 6.02 times 10 to the 23rd formula units. The moles cancel out, of course. Double checking my dimensional analysis, everything canceled out. I'm left with what I was looking for. That's correct. It's exactly what I'm looking for. Plug and chug in your calculator, and you get 1.53 times 10 to the 24th formula units of aluminum oxide. Check your significant figures. You were given 3. The final answer has 3. You are done. Let's go ahead and do the practice problems.